Now, how can we argue that this will always produce a prefix code? Yes?
Because you're partitioning the possibilities always by zeros and ones.
Exactly. So
As
continue, please.
in the example, you started with a 0 for B, you never touch 0 again.
Yes.
Then you partition the space into two, starting with zeros and starting with ones.
Exactly.
And the way you combine them up to the root of the tree ensures that there is a partitioning at each level.
Exactly. So another way to say the same thing would be that the code words in the Huffman procedure code words are the source letters always arrive or are always found on the leaves of a tree. And the code words are found by traversing the tree. So in this example, in fact, it was obvious just by looking at the diagram of finding the Huffman code that you could rearrange them on a tree just by simply unstretching all of what I've written. But we can take our code over here and draw a fairly straightforward tree. So B was over here, 0. Going down towards 1, we have everything else. Then if I have 0 and 1 like this, down here 1, 0, that's C. And under 1 I have everything other than B and C. And then I can split it again into 0 and 1, where I have A, that's A, here, everything else over here, again splitting, 0 and 1, here I have,
E.
E, yeah, because I erased this. E. Over here I have D. Over here I have F and G. So, because, remember my proof of the Kraft inequality. We found that if we could structure the code words on a tree like this, it must be a prefix code because no code word is a descendant of any other code word. So no code word can be the descendant of any other code word. And that's simply inherent in the way the Huffman code is structured. So remember my first example, we had A, B, C. So basically what we're doing is we're starting out with the leaves of the tree. We grouped, this is 1/4, this is 1/4, this is 1/2. We start out with these on the leaves, we just don't know at what level they are yet. So we group these together, and then we bump ourselves up to the next level. So this bumps A to the next level, with probability 1, and B, C grouped together to the next level. So in other words, it's kind of like this. We start out with all of my code words on the leaves of a tree. The structure of the tree is unknown at this point. But what I do is I group B, C together, and then I bump A to the next level on the tree. Like So basically, I always have the code words as leaves of a tree, so it's guaranteed that at the end of this procedure, I will end up with all these code words as leaves, which means that no code word will be the descendant of any other code word, so therefore it's guaranteed that the Huffman procedure will result in a prefix code. Okay, we're going to do two more examples. Firstly, we're going to do a non-dyadic example, where we actually have to do intermediate sorting. And then we're going to do a non-binary example. Things get a little different when we talk about non-binary Huffman codes. And I think that'll be enough for today.